to it. And then it clicks in place like that, okay? Now, you notice her chest is rising and falling. Underneath there are little pistons that are pushing it up. These elastic bands allow the recoil of her chest. If we wanted to show unilateral motion, this is how it looks mechanically in her. So let's say that we have a patient that is developing a pneumothorax. So in the software, we could go under respiratory, and to do that would be to increase volume outside the lung, interpleural volume. So I'm going to do it on the left-hand side. And I'm going to have this slowly increasing to where most of the lung is collapsed, and I'll do it over, say, a minute's time. Now, what you will notice is this side of the chest will slowly, it'll begin to expand, but it won't collapse. So if I do accept on here, over time, you're going to see a lack of motion on one side.
Oh,
Okay, which means also because there's no motion or no ventilation on that side, there will be no breath sounds. I don't need to go into the software and turn them off. It happens automatically because of this process. So what the students, if they were just palpating her chest, they would feel that one side is not moving, the other side is.
on auscultation, will they hear anything different? Or do
On
you
this
have to
side, they
set
won't
up-
hear anything
They
at
won't
all.
hear anything, okay. I
Okay?
mean, that automatically.
Yep, that
Okay.
automatically happens. But this is why it's important that you have them listening over the correct spot.
Right,
Let's say they were correctly over the speaker here and they're really hearing transmitted sound, and they miss the speaker over here completely. They may think, oh, she's not breathing on the right side, when in fact it's on the left-hand side. This is why the location is important in her, because everything's tied to, do they have the stethoscope in the correct location? Now, you cannot do a needle decompression in her, but let's say the students, or you were saying, what you would do is you would relieve that pressure by inserting a needle to relieve that, and then you could demonstrate that by coming in here. You could have a state that says needle inserted, and in that state, you could have this drop to 0 very quickly, say 5 seconds, okay? And now what you can imagine is now that air has been released, and now the one on the left side starts to function, okay? Similarly, if you wanted to simulate the fact that she was on a ventilator or there was an obstruction on this side, in the software where it gets to up top, it has bronchial occlusion. I can make it like she is occluded on the left side. There is a mucus plug there. And now I have again the paradoxical movement here, because this side isn't moving. You can't do this stuff on Juno, okay, because Juno doesn't do this. Okay? Only time Juno's chest will rise if you're doing bag valve mask. Okay? If she is not breathing as we did earlier today, so let me turn the alarms off. If I come in here and I get a good mask seal on here, you should see the chest rise on here. Now this on Juno would happen on here. You got a leaking out the port right here, but let's see if I can put
here's your
somewhere in a cap on here, but anyhow, that's okay.
I figured my golf tee that works.
Right, no, it's a little bit big. That's okay. Anyhow, you get the idea. If you're doing this,
I think we need a new Andrew.
yeah. So you see how it's all linked together. If the chest is rising, the sound will be generated. I don't need to go into the software and turn it on and off whenever it's going on here. And so now when I release this and let her start breathing again, by clicking off the apnea, she's now going to breathe at a faster rate and a larger volume in here until she blows off that CO2. That's what happens inside her, okay? You get a little bit of idea. So